When we talk about ratio, in fact, we are talking about comparison between two things. Let's say we have four squares here. Three of them are colored blue, while the last one is colored red. The ratio for these cubes or squares are 3:1. It means there are 3 blue squares to 1 square. A ratio says how much of one thing has been compared to another thing. It can be any quantifiable object. For instance, it can be the ratio of males to females, the ratio of apples to orange, or whatever you can count. One thing we need to know is how to write a ratio. There are different ways to write a ratio. We can use colon and say 3:1. And instead of colon, we can use the word 2. Say 3:1. Also, we can write it like a fraction, saying 3:1. All are the same. However, the most common way seems to be writing it as fraction. Many people are more comfortable to write it as fraction, like 3/1 or 5/2 or whatever the quantities are. Let's say we have 6 boys and 2 bicycles. What is the ratio for boys to bicycle? In this example, we are interested to compare two quantities to know how many boys there are for each bicycle. We can write it as 6:2 or 6/2. General convention is that the ratio must be reduced to its simplest form. In this example, we have 6 boys and 2 bicycles. So we will find their biggest divisor, which is 2. It can be divided by 2. And so the result is 3:1. It means for every 3 boys, we have 1 bicycle. Let's do another example. Let's say we have a bag and there is 50 pennies in that bag, 25 nickels, and there is 15 quarters. So let's say one asks you that what is the ratio of quarter to nickels and to pennies. So quarters to nickels into pennies. So the ratio is 15 to 25 to 50. Same order. Now we need to reduce the numbers to the simplest form. So we look to see what is the largest number that can be divided to 3 of them, that would be 5. Then that would be 5. Then we write it down. 15 divided by 5 is 3. 25 divided by 5 is 5. And 50 divided by 5 is 10. Meaning that for every 3 quarters, we have 5 nickels and 10 pennies, the exact same order. Now, let me first clear the screen. Now, what if I told you the ratio of male to female in an office is 3 to 4? 3 to 4 in an office where there are 35 employees. Right? This is our male and this is our female. Someone might ask you, how many female are in the office? You can also write this one as male to female. We know the ratio is 3 to 4. So it means for every 7 employees, we have 3 males and 4 females, right? Now, the question is, how many group of 7 employees do we have in the office? So we have 35 employees. We have 35 employees. The largest divisor for this fraction is 5. So we have 5 group of 7 people. Each group has 3 male and 4 females, right? Now we have 5 group, and in every group there is 4 female. We have 20 female employee. We can calculate the number of male employees that we have, which would be 5 group of 7. In each of them there is 3 male employees. That would amount to 15 male employee. Now, one might ask you, how many females should we add to this office so we have a ratio of 1 to 2? So we know that we have 35 employees. Also, we know that we have 5 groups of 7 people, of which we have 3 males and 4 females. We multiply the number of males in each group and we'll have 15 males and number of females, we'll have 20 females or in total. Now, we can do it in our head and say that to have the ratio of 1 to 2, we need to add 10 more females to the office. So if we add 20 with 10, we'll have 30 females. And then the ratio of male to females would be 1 to 2. Let me clear the board first and then we can do another example. In a school gym, there are 54 balls in a basket. The ratio of basketball balls to volleyballs and to handballs is 7 to 5 to 6. 54 balls in a basket. In order to know which sport is more in demand than others, we are going to examine the number of balls belong to each sport so we can say which sport is in demand. The ratio tells me that for every 18 balls, there are 7 basketballs, 5 volleyballs, and 6 handballs. Now, I have 54 balls and divided by 18 balls, and I have 3 groups of balls. And every group has 7 basketballs, 5 volleyballs, and 6 handballs. So I have 3 groups of balls. In each group I have 7 basketball balls. I have 21 basketball balls. I have also 3 groups of 5 volleyball balls, which is 15 volleyball balls, and I have 3 groups of 6 handball balls, which is 18. If the number of balls is a proxy for the popularity, then I can say the basketball sport is the most popular one. Let me clear the table first. There is another concept related to ratio, which is the scaling. By scaling, I mean you can use ratios to scale something up or down by multiplying it or dividing that. Let's say we are planning to scale something up. Let's say we have 4 squares. The ratio of the blue squares to red squares is 3 to 1. Now we wanted to scale it up. To do that, we have to deal with two sides of the ratio equally. We add we double the squares. We have now more squares. Actually, we have 6 squares in blue and 2 with red color, but the ratio remained the same. So here the ratio is also 3 blue squares to 1 red squares, even though there are more squares in the picture. Remember, whenever you are using ratio, always multiply or divide the numbers by the same values. Let's say you have a ratio of 4 to 5. If you want to scale it up, you have to, for instance, you want to double the value, you multiply it by 2 and you'll have 8 to 10. Let's say you have a ratio of 4 to 6 and you want to scale it down so by half, so you divide it by 2 and you'll have a ratio of 2 to 3. Let's use another example for scaling down. Let's say we have a recipe for cake, and in that recipe we have 3 cups of flour and we have 2 cups of milk. This recipe prepare cake for 8 people. Now we have 4 people as guests, so we want to scale it down. In order to do that, we divide them by 2, so the ratio of flour to milk, which is 3 to 1, will be 1.7 to 1. It means for every 1 cup of flour, you'll have every 1.5 cups of flour, you'll have 1 cup of milk. That is called scaling down. Let me make some room here. Now, let's get back to the concept of ratio. We use ratio to make comparison between 2 or more things that have same value. So far, we practiced to compare numbers by multiplying or dividing each term in the ratio by the same number. For example, we divide both terms in the ratio of 30 to 60. We divide them, for instance, by 3. Then we get the ratio 10 to 20. Or if we divide the ratio by 10, then we get 1 to 6. There are other ways to find out if 2 ratios are equal. One way is to divide the first number by the second for each ratio. If there is quotient in it, and the quotient are equal, then the ratios are equal. Let's say we have 2 ratios, 3 to 12 and 36 to 72. Are these 2 ratios equal? To find the answer, we divide both ratios. We divide 3 by 12 and we get 0.25. We divide 36 by 72 and we get 0.5. Since the quotients are not equal, then the ratios are not equal. Let's do one more example. Let's say we have a ratio of 4 to 20 and 6 to 30. So, by the same rule, we divide 4 to 20 and we get 0.2. We also can divide 6 to 30 and get same quotient. So since they have same quotients, then we can say these two ratios are equal. Now let me make some room here, then we can continue. Now, how to read a ratio? We have two numbers in a ratio, and each of them called a term. We have first term and we have second term. When we are asking the question, we usually say what ratio has x to y. For instance, what ratio has 28 to 7? What ratio has 28 7? When the first term is larger than the second, we'll say 28 is 4 times 7. So we respond with a sentence. In our sentence, we always begin with the first term and end with the second term. If we are asked what ratio has 5 to 15, for instance, 5 to 15. Let me write it the same style. 5 to 15. This is called inverse version or inverse ratio of 15 to 5. Then our response would be 5 is third part of 15. 5 is third part of 50. Let's say what ratio has 12 to 6? 12 is 2 times 6, or you can say 12 is twice as much as 6. Or even you can say 12 is double 6. But you always use a complete sentence. But if the question was what ratio has 6 to 12, then we would say 6 is half of 12. We also can say 6 is 50% of 12. As you can see, ratio, like percent, expresses a relationship between two numbers. Using different complete sentences, we can express this relationship always. Next subject is proportion. Let me make some room here before we start proportion.